Our universe has a beginning. It wasn't always here. We call this beginning the Big Bang. Imagine everything squeezed into a tiny point smaller than an atom. Then about 13.8 billion years ago, it exploded. The Big Bang wasn't like an explosion in space, it was the expansion of space itself. Think of a balloon with dots on it. As you blow air, the dots move apart like galaxies in our expanding universe. In the first fraction of a second, the universe was incredibly hot and dense. It was so hot that matter as we know it couldn't exist. But as the universe expanded, it cooled. This cooling allowed for the building blocks of matter to form. These were tiny particles like quarks, electrons, and other subatomic wonders. The early universe was a chaotic soup of these particles, constantly colliding and interacting. It took hundreds of thousands of years for the universe to cool enough for atoms to form. Atoms are the basic building blocks of everything we see and feel. Their formation marked a crucial step in the evolution of the cosmos, setting the stage for the emergence of stars, galaxies, and eventually life itself. The story of the universe is a story of change, of cooling, and of the gradual emergence of complexity from simplicity. After the Big Bang, the universe was like a giant cosmic soup of tiny particles. These particles were so small that you couldn't see them. Even with the most powerful microscope, they zoomed around at incredible speeds, bumping into each other. As the universe cooled, these particles started to stick together. First, quarks combined to form protons and neutrons. Protons have a positive charge, like the plus sign on a battery. Neutrons have no charge, like a neutral wire. These protons and neutrons are the heavy particles that live in the center of atoms, forming the atom's nucleus. It took another 380,000 years for the universe to cool enough for electrons to join the party. Electrons are much lighter than protons and neutrons, and they have a negative charge. They are attracted to the positive charge of the protons, much like magnets attract each other. When electrons combined with protons and neutrons, the first atoms were born. The most common atom in the early universe was hydrogen. It is still the most common element in the universe today. The formation of atoms was a pivotal moment. The universe was no longer a sea of scattered particles. It now had the building blocks for stars, planets, and even life itself. The early universe was not a uniform sea of atoms. Gravity, the force that makes things fall down on Earth, played a crucial role. Gravity pulled atoms together into giant clouds of gas and dust. These clouds became denser and denser over millions of years. As the clouds got denser, the pressure and temperature at their centers increased dramatically. Eventually, the pressure and temperature at the center of these clouds became so intense that hydrogen atoms began to fuse together. This fusion process, like a giant cosmic furnace, released enormous amounts of energy. This energy is what makes stars shine. The birth of stars marked the end of the cosmic dark ages, a period when the universe was filled with neutral hydrogen gas. Stars are the fundamental building blocks of galaxies. Galaxies are vast collections of stars, gas, dust, and planets held together by gravity. As stars formed, they grouped together under the influence of gravity, creating the first galaxies. These early galaxies were much smaller than the majestic spiral and elliptical galaxies we see today. Over billions of years, galaxies collided and merged, growing larger and more complex. Section 4. Our galactic neighborhood, the Milky Way and the Solar System. Our Sun is just one star among billions in the Milky Way galaxy. The Milky Way is a spiral galaxy, shaped like a giant pinwheel, with long, winding arms. From our vantage point on Earth, we see the Milky Way as a band of light stretching across the night sky. It's like looking at the edge of a plate from the side. Our solar system resides in one of the Milky Way's spiral arms, about 26,000 light-years from the galactic center. A light-year is the distance light travels in 1 year, about 5.88 trillion miles. Our solar system formed about 4.6 billion years ago from a giant cloud of gas and dust. Gravity pulled most of the material toward the center, where it eventually became hot and dense enough to ignite nuclear fusion, giving birth to our Sun. The remaining material swirled around the newborn Sun, forming a disk. Within this disk, dust and gas collided and clumped together, gradually growing into planets, moons, asteroids, and comets. The inner planets, Mercury, Venus, Earth, and Mars, Our rocky planets, the outer planets, Jupiter, Saturn, Uranus, and Neptune, are gas giants. Our solar system is a dynamic place with planets orbiting the Sun, moons orbiting planets, and asteroids and comets hurtling through space. Section 5, stellar fireworks, supernovae, neutron stars, and black holes. Stars may seem eternal, but they have a lifespan. Just like everything else in the universe, the lifespan of a star depends on its mass. Massive stars live fast and die young. They burn through their nuclear fuel much faster than smaller stars. When a massive star runs out of fuel, it can no longer support its own weight. The core collapses in on itself, triggering a catastrophic explosion called a supernova. Supernovae are some of the most powerful events in the universe. They can outshine entire galaxies for a brief time. The explosion scatters the star's outer layers into space, seeding the interstellar medium with heavier elements like carbon, oxygen, and iron. These elements are essential for forming planets and even life. The remnants of a supernova explosion depend on the mass of the original star. A star's core can collapse to form a neutron star. Neutron stars are incredibly dense objects, packing more mass than the Sun into a sphere just a few miles across. If the core is massive enough, it will collapse into a black hole. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. They're cosmic vacuum cleaners, sucking in anything that gets too close. Supernovae, neutron stars, and black holes remind us that the universe is a dynamic and ever-changing place.